Welcome students. Today we are going to discuss about electronic circuits unit 2 MOSFET amplifiers. MOSFET metal oxide semiconductor field effect transistors. Metal in the sense it is an aluminum oxide SiO2 layer. Semiconductor is a silicon. Field is electric field. So this comprisingly we call it as MOSFET metal oxide semiconductor field effect transistor. It is having four terminals: source, drain, gate, and substrate. Always source and substrate connected together, and it is grounded. Today we are going to discuss about a common source, common drain, and common gate configuration, as common base, common emitter, common collector in the BJT. So as like the first step, so here common source. Source in that source, the middle term will be the ground, source will be the middle term, and gate will be the input side, and drain will be the output side. So here input we have to give in the gate terminal, and drain have to get the output, and the middle terminal has to immediately grounded. And one thing you have to remember during this logic, drain never be act as the input, and gate never be act as the input. Gate never be act as the output. So this is the logic behind this. So whatever the letter is telling is common, that letter has to be coming in the middle. And input side you have to connect the voltage source with the resistor, and output side you have to connect the voltage, or have to take the output voltage. And middle term, that is your, in case of common source, if it is source, it has to be immediately grounded. And then parameters, have to find the parameters, how we can be explained, or how you can represent the common source drain gate by using the hybrid pi model. So here see, the first terminal, it is a hybrid by NMOS model. So here, gate terminal, drain, and what are the letter is source common, that letter has to be in the bottom. For it is common drain, drain is to be the bottom. Common gate, gate is to be at the bottom. And if it is NMOS, gate carries positive symbol, and if it is PMOS, gate carries negative symbol. And the voltage drop across is VGS. And the current source always flow from drain to source if in the case of NMOS, and it will be go from source to drain if in the case of PMOS. And the letter has to be written as, for NMOS it is written as GMVGS, and for PMOS it has to be written as GMVSG. So this is the way you have to write. And R naught resistor, always a high or output resistance, it has to be connected parallel to the dependent current source, which is represented in the diamond shape symbol. So this is the way you have to explain. This is for the hybrid pi model for NMOS, and this is for your PMOS diagram. The next thing, I have to differentiate the input impedance as well as the output impedance. In common source, in general, always your input and output impedance will be high. That's why it will provide both voltage gain as well as the current gain. But in the common drain, it having high input impedance but low output impedance. Therefore, it is only suitable for the voltage gain. And common gate calculation, low for input impedance and high for output impedance. Hence, it is applicable for the current gain calculation. Thank you, students. This video is about your common source, common drain, and common gate MOSFET amplifiers. Thank you, students.